Hello everyone. Today I'm going to be going over current divider, and I'm going to be going over what it is and how to derive the formula for current divider. So, if we take a look here, a current divider is essentially a circuit that consists of a current source and two resistors that are all in parallel with each other. And a quick note, the formula is going to be derived from Ohm's law. So if we look below, which circuit is the current divider? Pause the video and try to figure it out first. So if you picked the circuit on the right, well, you're wrong. That's in series. And if you picked the circuit on the left, then you're correct. It's in parallel. And the way we could tell is they're sharing two or more nodes. And there's one node right here. And there's a bottom node here. And you could clearly tell that all these elements are sharing two or more nodes. And if we look at the definition, it says parallel. The current source and the two resistors have to be parallel. Therefore, it's the left circuit. And moving on, so how can we derive this formula? Well, if you recall with Ohm's law, we have V is equal to IR. And when adding up two parallel resistors, you could either take the inverse like this with this formula or use this formula for parallel resistors. And I'm going to assign resistors. So I'll call this R1, R2, and I'll call this I1 because the current splits with the current source. And I'll call this I2. And I'll call this current source I. And I'll label my first node, which is over here, which is all of this. And a very important circuit rule is that the voltage across the same node is always equal. So the voltage at this part of the node will be equal at the voltage at this part of the node, which will be equal at this part of the node. So any point of this node, the voltage will be the same. So knowing that, we could say that the voltage over here is equal to the voltage over here. So I could say that V is equal to, let's call the other one V1. Let's call this point, let's label 2 points. So I'll call this point V, let's call this part V, and let's call this part V1, and they're both equal. So the next step is to add the two resistors. So we have the voltage here, and if we add the two resistors using the formula, we'll get a circuit like this. And our equivalent of that is R2 times R1 divided by R2 plus R1. And the current source stays the same. And if we use Ohm's law on this circuit, then we could get our voltage. If we use V is equal to IR, so multiply this I by this resistor, or this big equation, this parallel equation, then we'll get our voltage V. We'll get our voltage V. So we have I, I'll write over here, I times R2 times R1 divided by R2 plus R1 is equal to V1. Well, if we just take I1 and multiply it by R1, we get our Ohm's law. So multiplied by I1 times R1. And if we want to find the current at I1 specifically, Then we move R1 to the other side. So now we have I1 is equal to I times R2 times R1 divided by R2 plus R1 multiplied by R1, and our R1 cancels, and we're left with I1 equals I divided by, sorry, there's also R2 on the top, multiplied by R2 divided by R2 plus R1, and that is our current divider equation. It's a pretty simple equation. So if you want to find the current at I1 at this part, the current going through this resistor, then you use this equation. If you want to find it for I2, then you do the exact same thing, and instead of writing I1 times R1, you'd write I2 times R2. So essentially, let's say I want to find the current at I2. I replace this with I2 and R2, and instead my R2 cancels, and my equation is this if I want I2. So it's just the numbers get changed, or the resistor gets changed on the top. And that's pretty much it for this video. I just want to go over current divider and where the formula comes from, because most professors don't really go over that. They just show you this is the formula and apply it to this circuit. And I'll be going over examples later down the road, and hope you enjoy.